Some of the operations shown on the table and radial arm saws are for photographic clarity. We strongly recommend that you work with the guards in place. Doors are often the focal point of a cabinet. A decorative door front will add a touch of class to a well-constructed cabinet.
I think you can see since the last video we've added the doors to the little nightstands, and this gives you an idea of what this subject matter will entail. We're going to talk a little bit about the orientation and nomenclature of doors and then show you some types and how we can change them to make them different. There are three basic types of doors that we work with. One of them is what we call the flush door. And a flush door would sit in the opening, that is between the two stiles and rails, so that the front of the cabinet will be flush. Now these doors usually are hinged on a butt hinge one way or the other. And usually as you look at the cabinet they'll call it hinged right or left. There is another type that's a little bit different. This is what we call a 3/8 lip or 3/8 offset. This door has a notch or a rabbet cut on the sides of it. This is usually 3/8 by 3/8 on a 3/4 inch thickness door. The neat thing here is you've got a little more latitude as far as movement. You don't have to be quite as precise with the fit, and this is desirable in many cases. Another type of door is what we call the overlay door, and it simply lays over the opening, that is to say right on top of it. A little bit different approach, and you're really not nearly as worried about dimensions. One of the things we have here is a little finger groove put in the door. This finger groove allows us to pull the door open without any type of hardware and gives the cabinet a kind of a clean, modern look. Some people prefer this for kitchen cabinets. We use the same approach here in the shop. This is common. So once again, these are the three common types of doors. First, the flush with the flush front. Then what we call the lip or 3/8 offset. And then finally the overlay where it lays over the opening. Now, let me direct your attention to a flush door that's been fitted here. This is probably the hardest door to make, simply because it has to fit an opening. If the opening is out of square, the door has to be made out of square. When you open the door, there should be no interference as you open it, which means there has to be a slight bevel planed on the door. Usually some kind of magnetic catch or other device has to be used because these types of hinges, which are called butt hinges, do not have any self-closing mechanism. In the case of the 3/8 lip door, that is where we have a lip around it, we can use a hinge that is self-closing. That is, it has a mechanism that allows it to pull the door down. In addition, we don't have to worry about our tolerances so much. We can make this rabbet smaller than the opening, and that would allow us to turn the door in the opening and make it a little easier. It looks nice. Again, one consideration you'll always have is that the lines of the drawer should match up with the lines of the door. In this case, there's no radii routed on the edges here, and we'll do that later. We just put it on for illustration purposes. The overlay doors just lay over the opening. They're made as a slab. They're usually the most inexpensive to make. Usually you're cutting them out of a sheet of plywood, routing the back side of the edges, and that kind of hides the edge grain of the plywood and gives it a real decorative solid wood appearance. Again, in many cases the drawer grain will match the doors. That is, it'll be an extension. So these are some of the things that we look at with the styles of doors. Let me direct your attention to a few other types of considerations with doors. In some cases we have a frame that we make up, and this frame then can have additions to make it simple or complex. From the simple end, we can use a plywood panel. Now when we snap a plywood panel in here, we're not so worried about expansion and contraction because dimensional stability is greater. We can decorate this with certain overlays or appliques that allow us to get a real nice look to it with relatively little expense. These would be routed out of solid wood, cut and routed out of solid wood. We can change that look very easily by changing the style that we put on here. Here's a few that we cut just to give you an idea, and these certainly are not the only ones that you could use. If you're building a gun cabinet or a stereo cabinet, such as you might have seen in my table saw or radial arm saw book, you will be concerned with putting a glass panel in the door simply because you want to display what's in the opening. Glass takes a few more considerations, and we'll be discussing a little bit about that as we get into making doors of this sort. We can also get a little more decorative here, and here we've got a quarter sawn raised panel that we've glued up several pieces to make, and this gives us a real nice decorative look. The advantage of this type of door is because the panel slips in from the back, it can be changed. If you broke a piece of glass, you could pop it out through the back and change it very easily. In a little fancier style, we have a door where the panel is actually trapped. That is, it can't get out. When you put this door together and glue it up, the panel goes in the middle. And when that happens, it's locked in there forever. If you break a panel, you literally have to just about destroy the door or replace the entire thing. So this is a little bit of a disadvantage, but many people like this solid look. This particular door is oak with a nice raised panel, all glued up and decorated nicely. Now, in some cases we do some compromising. Here we have a 3/8 offset or lip door that we have actually taken a piece of 3/4 inch plywood and put a decorative molding on. This molding has been glued and nailed around the door, and this gives us our 3/8 offset so that we can install our hinges, and it gives it kind of a raised panel feel without all of the labor and extra solid stock that you would need to do that. This type of molding is bought by the linear foot, and it's very useful for the types of cabinets that we put in kitchens and other places, bars and decorative areas in the house. Now I want to stop here for a minute. I'm going to get some other materials and help you identify the joinery and how the doors fit together. So I'll be right back with that material. I brought in some doors to help you understand the nomenclature terminology that goes with doors and maybe have a better idea of how they fit together, get an understanding of the working parts. Generally, when we look at a door, just like a faceplate, we have the rails, which are the horizontal members, and the stiles, which are the vertical members. Anything that goes in the middle is usually referred to as a panel. In this case, we've got solid wood panels, we could have plywood panels, and we talk about glass panels. All of these fit in like so. The joinery that we use to put a door together generally breaks down into one of two types. In some cases, we use what we call a lap joint, where the two pieces overlap each other. Now, in some cases, like an overlay door, where the door lays over the opening, people don't like this because they say that the grain shows. Now, to me, I think that's a nice touch, but some people say that's really not desirable. This type of joinery works very well for a door where you want to slip the panel in from the back, for example, where you might be using glass. This panel here has been routed out to accommodate glass or wood. The interesting thing about this door is when you look at the end, you don't see that end grain because we put a 3/8 lip or offset on the door, and we actually routed away that end grain when we did that. So in some cases that may be a valid criticism, in other cases it's not. This is a relatively simple joint to make, and it looks good. A little more complicated method is when we use a groove type door, and that groove accommodates a panel. For example, the panel will fit in like so, and it's trapped in there. The joinery here is what we call mortise and tenon, in this case a haunched mortise and tenon. This is the tenon part, and the haunch is cut like so. It steps down, and what that does, it allows us to hide that groove or fill that groove when we assemble the door. Now, the reason we bring this haunch down a ways is if we decided to route this same type of rabbet or 3/8 offset, we don't want to route through it into our opening. This would look tacky. In fact, I think I've got an example here. Let me bring it in and show you what can go wrong. If the joinery is too close to the edge, you can see that you can actually route into the opening. So we can look in and see that tenon, and if we didn't do a real good job, everybody's going to know about it. So what we want to do is hold those dimensions in. These are all considerations that we'll be talking about here in a minute when we talk about measuring and planning a door. This particular door here can be broken apart. All of the joints were custom fit. That is to say that the rails and the stiles all have been custom fit, and you can see that we marked them D and D, B and B, and so forth, and that helped us get a better fit of how they go together. The lap joints weren't quite as critical, especially if you hold your dimensions tight. That won't be a problem. Well, these are the considerations and the two types of joinery that we'll be exploring in this video on doors, and I'm going to get the dimensions out so we can do some measuring, get the materials out for dimensioning and drawing a door so you can understand how you fit a door to an opening. So I'll get those materials and I'll be right back. I measured the opening for the cabinet for fitting a door, and I'm ready to do some things with that. I'm going to take the dimensions and move along. Now, if you're building the nightstand or the hall chest, you'll find that there are dimensions for a door available in the book. And if you're building the entertainment center or any of the other projects in here, you'll find that there are details on the doors as well. Now, in any case, it's a good idea to make a drawing up if you need to. In most cases you do need to, because your opening may not be right. As you saw me measure, I measured 3 different places. Maybe the opening isn't square. You may even want to check a corner to see if it's square, and that's the point of reference then, because now you can work off a square corner of the door. In the case of the flush door, we've got our dimensions marked out here. The opening is 11 by 11, and we now know that our pieces, at least the vertical pieces, the stiles, will have to be 11 inches long. Now, we don't know how long the rails are, but we know they go in here in that haunched mortise and tenon joint. It may be a good idea to make up a detailed drawing such as this one. Now, what we've done here is made like a detail of the corner, and that really just shows what you see here, how these are going to fit together. And you can see that this piece goes in, well, 3/4 of an inch is showing here, and there'd be 3/4 showing here. And since this is 11 across, we can now subtract 3/4 and 3/4, an inch and a half. We now know that the piece will be 9.5 inches long. So to make this door, we need 2 pieces 9.5 long and 2 pieces 11 long. And this helps us develop our bill of materials. All of these considerations are important when you build the door. There's one other consideration here. You'll notice that I have a 7 here, and that reflects what we call the shoulder to shoulder dimension. This is very critical too, because this limits or controls how far apart the 2 stiles are from the rails. And if we change this just a little bit, we change the overall size of the door, and we can really either positively or adversely affect how it fits the opening. Very important stuff. Now in the case of a 3/8 lip door, there's a few things that we have to change. You saw that in this case we had an 11-inch opening and 11-inch door. Here, when we think about what we have an opening that's 11. We say 3/8 offset. 3/8 plus 3/8 equals 3/4. Make it 11 3/4. Yet here I call for 11 1/2. Why is that? Let me show you what happens. In the case of making it the larger of the two, what you find is you have what machinists sometimes call an interference fit. That is, you can't even get it into the opening because it's the exact size. This makes it very difficult to fit and it's time consuming. So what I usually do is only add 1/4 on each side. Now you say, well, that's almost so sloppy it will fall through. Well, one thing we've forgotten. Let's put the hinge in there. Let's see what happens now. That's a pretty respectable fit. After all, there's got to be a little room for that to clear when we open it. So these are all things that you'll want to consider. Now, the first few times you make 3/8 offset doors, you'll make them exact size, and then you'll have to trim them down and make them again. After you've done them 2 or 3 times, you'll decide that it's a good idea to add only 1/4 inch to each side so that they're a little sloppy and you'll feel better about the fit. Now, a lap door, in this case, we made lap joints on this lip door, and since we're supposed to be 11 1/2, we are 11 1/2 on the money. And one of the things I pointed out in the first video was the advantage of lap joints is we know that these pieces go to end, top to bottom, so all 4 of these pieces would be exactly 11 1/2 inches long. This makes the calculations a little easier. The door then will be routed on both sides, and we'll see how that's done later in the video. But this gives you an overview of how to measure a door and how to determine just how long the parts are and how wide they are. Width is very important. For example, we call for 2-inch pieces and we use 2 1/16. We've now added a 1/16 to this side and a 1/16 to this side, or an 1/8 total. This makes it very difficult to fit a door. So it's very important that you hold those widths uniform. And in some cases, thickness can be exactly the same kind of problem, because if the joint goes off the center of the piece, one piece is thicker than the other, it can ruin that fit as well. Well, this gives you an overview of the joinery. I think it's time to get some chips on the floor. I'm going to get some stock out now, and we're going to talk about how we proceed to make these joints and how we make the parts. So I'll get some wood now, and we'll be moving right along into building some doors. We're set up now, or we're about to set up to cut the lap joints to make a door for the nightstand. As you noticed earlier that we always mark our stock. We talked a little bit about that when we laid out stock. And we did the same thing in the first video where we did it on the table saw. What I want to show you here is how one would do it on the radial arm saw. I've set my dado depth to half the thickness of my stock now. I've got a nick here. I think you can see it. This little nick then will line up with the edge of this dado cut. What I'll do is I'll turn the piece like so and position it so that it's right there, lined up with the outside edge of the dado cut in the fence. Now I can use this piece as a stop. And I think you can see that I've got a rabbet cut on the underside here. That rabbet will keep the sawdust from accumulating in this corner and throwing off my dimensions. So let's clamp this. That looks pretty good. Well, we'll try this first cut now. I'll set the extra stock off the saw. We don't want anything to get in the way of the cut, and we can bring them in as we need them. This fit is good. I'm pretty happy with it. A little cleanup work with a chisel maybe. Could raise that dado head just a hair, but I'm satisfied with that. A little sanding would take care of that. So I'll go ahead and cut the rest of these pieces, and I'll meet you back at the bench, and we'll glue this up.
After cutting the lap joints, any high spots may be removed with a sharp wood chisel. After all joints have been cut, we are now ready for the dry fit. Preset all clamps with clamp pads between the wood and the clamp if C-clamps are used.
These are the parts that we cut at the radial arm saw, and you could cut them at the table saw as well. They're ready to go here now. All of the fits are good, and we've got another one here as backup. I'll set things the way I want them. I'll bring them just slightly off the edge of the bench. This is essentially the same as the faceplate glue up that you saw in the first module on building the cabinet. Don't overdo it with the glue, but be sure there's enough to get the job done. Make sure you get a good bond. Put a clamp under, or a clamp pad under. Clamp pad over. Try to pull them together relatively snugly. Started. Now I can pull this up with the bar clamps once I've got all of the pads on, and I won't tighten the C-clamps as tight as they need to be for that very reason. You can see I'm getting some squeeze out there. Things are square, so I'm pretty happy there. I'll snug these up just a little more, but still not real tight. Turn this like so. Put the other clamp on. Now I can then snug these up again if I want. Now I can leave this to dry, and once it dries I can clamp the other one up. So I'm all set for that now. I'll leave this, sweep up the shop, or do something useful. I got my router set up for cutting the rabbet here, and I've got an example of what we're doing to show you. This is the lap joint door, and we've routed out the inside here so that we can put a panel in. Now the outside has been rabbeted as well, 3/8 rabbet. This is the lip that we need for the door to fit into the opening, 3/8 offset. Now one thing that happens when you route both sides here is that you really reduce the cross section of the door considerably. And this is a 2-inch door, and a standard hinge just fits on it when you route both sides. So you want to take that into consideration on the dimensions of your door. The depth of the two rabbets is different. This one is a 3/8, this is more like 5/8. The increased depth on the inside allows us to put a piece of molding in here if we want to, and that molding then will hold the panel in position. These will have to be squared out later. I'm going to route half of this and then I'll show you how these are squared out. I've got my piece clamped. Remember, good face down, so we're routing the back side of the door. This is very important. You don't want to route the good side and then have the bad side exposed. So I'm going to route around here and show you just what happens. I'll change to my final depth setting here. Now I can release my piece and clamp the other side. I'm not going to do that just now. I'm going to go on and show you how we square a corner out so you can get the feel for what's happening here. Now that you know how to route that, I don't think that'll be a problem. When we mark this, usually what I do is I take a square of one sort or another and mark a line both ways. And that's the area that has to be removed. So once I've got that decided, it's a good idea to clamp my piece. That keeps the rebound and the bouncing to a minimum, and also keeps the impact on the front of the door down. Because it's down tight, it won't slap the work all the time or slap the bench. Now line it carefully, just tap it. You don't want to take it out all at one time, and your chisel should be a little sharper than your teeth. You don't want these to look like they're cut by a beaver. Go very easily, work your way down. If you see some splitting, it's a good idea to consider sharpening your chisels before you go any further, because you don't want to damage that door or ruin the appearance of it. Remember also that we'll be putting some molding in here, and that molding has to fit square. So if the corner is a little irregular, it's going to make it more difficult to put that in. Now I think you'll agree that that follows pretty nicely. Nice clean lines. We owe that to sharp chisels, sharp tools. You'll find that any of this fine work you do on fitting doors, it's important that you have sharp hand planes or sharp chisels, because Anything less will just damage the workpiece. Okay, we're going to get the rest of these cleaned up and move on to other parts of the door assembly.
If a plain panel is going to be used, 1/4 inch hardwood plywood is recommended. The plywood has a decorative veneer on the front side and may be bought in 4 by 8 foot sheets and cut down to the desired size. This eliminates any edge gluing which may occur if solid stock is used. Measure the distance of the inside of the door frame and cut the panel to size on the table saw.
We're prepared to put a glass panel or a wood panel into one of these doors, and we'll be using some small pieces of wood molding. I'm going to show you how to do this in just a minute, but I think as important as it is to know how to install it, it's also important to know how to make this molding, because these thin little strips are kind of delicate and there's some actual work too involved in making those. So let's go over the table saw and I'll show you a technique you can employ to make this for doors of any size. These wood strips that you saw at the bench are simply small pieces of 1/4 round. We use the whole glass or wood panels in position. We can make these on the table saw with a shaper head, and what we've done here, if you look at this piece, you can see that we've cut a radius around here, and there's a slight shoulder here and here. Those shoulders then will be the marks for our saw cuts so that we can make this molding. Now, this was my test piece, my setup, and I've got 2 pieces that are equal width that I can shape on both edges. So what happens is I get 2 strips off this edge, 2 strips off this edge, 2 off this edge, 2 off this edge. It depends on how long, depends on how big the door is as to how long these pieces need to be. You always want to add about 3 or 4 inches to the length. If you had a 60-inch door, you'd want a 64-inch piece, so if there's a little deviation at the end, you can cut it off and get a better fit and not waste much wood. So once you've got the pieces cut and you've decided, you can set the shaper head up as I have here, and I'll show you how I did this. This cut does not make a perfect round, so I've cut it 2 ways. Your shaper heads may be a little bit different, and that will pretty much control how this job is done. We've got 2 pieces that are the same width exactly, with the edges cut like so. Notice that we've got a little width here so we don't have a real tough time making these thin rips. I'll show you how to make these rips in just a second, and then we'll have our molding made. So give me a minute to change to a saw blade and we'll proceed. We're all set now to make our cuts, and these are really nothing but rabbet cuts. The way we set it is important though. Our first cut will be on edge, and we want to set our blade so that it cuts just a little deeper than that shoulder that we made with the shaper head. And then we set our fence so that the blade is oriented with that shoulder. I'll make a test here, just a second. There's just a little wood there, and we can sand that off. That's fine. And we'll make this cut on all the edges. Now we make a rip cut through the board. We position the blade so that we leave just the molding. That shoulder again will determine where we need to be. And we'll raise the blade height so that it cuts completely through, and we'll just skin it and test it. There's our two pieces of molding and some waste stock in the middle. The neat thing about this is we're cutting in this fashion. Our pieces fall off out here. We don't have a thin strip trapped between the fence and the blade, which could cause a kickback and be dangerous. So with this setup, we're pretty good. We can cut both sides and then shut it off, turn the piece over, and the same settings should apply because they were the exact same width when we started. This is very important that they be square and the same width to do this. Sort our moldings away from our waste stock. I've turned this around. Once the blade stops, we can set this again. And that looks right. Now if we had a lot of doors to do, we would probably prepare 3 or 4 more pieces so that we only had to go through this one time. Obviously these boards are good for something else later, or we could go back and cut a couple more edges off each side. This is good use of the material, and it makes the job safe, which I think is very important. So we'll go back to the bench and work on these doors. This overlay door is a piece of plywood. You've seen this earlier in the video where we simply attach these moldings. These are cut as miters and they wrap the entire object. This frame or this door is the mate to it, and it's all done. I could show you simply by nailing this on how this door goes together, but I think it would be better if we just went to the table saw and cut some of these. Before we do though, we can take some measurements. We measure the size of the panel, for example 14 inches. On our moldings, the distance from the miter at the rabbet will be 14 or slightly greater, and that'll allow a little bit of deviation in case the sides wander a bit. And so that determines our dimensions, and we'll show you how we lay these out at the table saw. So I'll get some stock and meet you at the table saw. We've got the same miter setup we had in the first video for cutting the top of the nightstand. What we're doing here is cutting the wrap molding. Now this miter has already been cut. We'll set this aside. But to cut these, since there is a rabbet on here, if I were to cut it like this, I get an angle to my miter or a compound miter. By using a stool or a piece of stock like so, I can support this piece. If you look here, you can see that this doesn't ride on the ground, but it wraps this piece and it's held in a true plane. So we can get a very accurate miter this way. I can get a pretty good idea where I need to be. I don't want to waste too much because I've cut these almost to exact length. So now all I've got to do is make this cut. Now when we measured the other piece, we measured the shoulder length. That is, the distance from the end of that rabbet to this rabbet is the length of the plywood. So what we're doing now is extending those lines, and we marked the short point of the miter here. We can now use this to position this piece. What we'll do is we'll bring it up so that that line is set like so. Now we can clamp a stop. This stop will control length, make all of them uniform, which is one of the keys to getting quality miter work and tight miters. Now if you're doing an entire kitchen, you might have 6 or 8 doors that are the same size, so this would be very important. So we can cut this piece and then cut this, and this is how they'd be matched up. The check for uniform length is to put them back to back, and it's a beautiful fit. This is the way we'll cut all of the pieces, so we'll take all the measurements and cut them, and then go back to the bench and fit them. I'll go now and cut some more blanks up and finish this job. Well, we've got our 2 doors made up. There's a few things we have to do yet. Of course, we're going to fill and sand these. We may want to fit the doors first. We'll use the typical 3/8 offset hinge, and it will mount like so. Very easy to install. We use the same techniques you saw for the overlay hinge installation. These doors are about ready for hinges. I think I'll let this glue set up, and I'll pick up. Got another nail to put in here. It seems to be pulling away. I'll go ahead and pick up the hinges and the hardware, put them on the doors, and then we'll fit them on the cabinet. I've got the last of the screws marked and ready to install. I'm going to pull my shim out of here. I use this shim to balance my exposure and cover the openings. I tried to line up my edges here so the doors and drawers are right above each other. Now I'll set these screws. I can check the operation. No noise with these. I've still got some filling to do on these, So I'll remove these doors in a bit, fill those, and then I can take things apart, do the final sanding, and prepare to finish. So all the installation work is done now.